We're going to cover section 8.4 today, rhombuses, rectangles, and squares. Our objectives is to be able to use properties of rhombus, rectangles, and squares, and be able to classify types of quadrilaterals. Okay, so the key, this is kind of, this stuff about rectangles, rhombus, and squares is kind of memorization. You have to know the different characteristics of the shapes. And we're gonna go over their special characteristics, so you can distinguish between the three and know what the properties apply to each one. Rhombus, first one we'll talk about. A quadrilateral is a rhombus if and only if it has four congruent sides. Don't confuse rhombus with square. Okay? A rhombus, the angles, the consecutive angles don't have to be the same. Right? It's just the four sides are congruent. Rhombus has four congruent sides. Rectangle. A quadrilateral is a rectangle if and only if it has four congruent angles. Rectangle has four congruent angles. So it's a four-sided shape. It's got four congruent angles. What do those angles have to be if they're congruent? What do they sum to?
360.
They sum to 360. All four are the same. What do they have to be? Yeah, they have to be 90. Right? So you could take this a step further and say it has four right angles. That's what makes something a rectangle. Square. Do you need a notes packet?
Yeah.
Anybody else need a notes packet? Kayla? We just started the section here. We talked about characteristics of rectangles, rhombuses, and now we're doing square. Okay, so a square, something is a square if only if it is both a rhombus and a rectangle. So that means if and only if all its sides are the same and all its angles are the same. A square is special. Rhombuses and rectangles, you could kind of think of them as cousins, right? One has congruent sides, one has congruent angles. All right? Then a square is a combination of both of those. Congruent sides, congruent angles. And those angles would be right because it's a square. Any questions? Example, for any rhombus, QRST, decide whether the statement is always or sometimes true. What I would do to help me answer this question is I would just sketch QRST. So we'll sketch a rhombus and we'll label it QRST. Doesn't matter where the letters go. Now, when you look at that, for the rhombus, what would you say about Q and S? Are they always the same or sometimes the same in a rhombus? Q and S. They're across from each other. Okay? Here's how we can think of it. What can we classify as a rhombus in a more broad category? What is a rhombus? Is it a parallelogram? Yes. All three of these shapes are parallelograms. What do we know about the opposite angles in parallelograms? Eric? They're congruent. So because a rhombus is a parallelogram, I can say QS always is equal to, Q is always equal to S. Q is always congruent to S. Okay, what about Q being congruent to R? We can pretty much rule out always, can't we? It's obvious when I look at this rhombus, there's no way these two are congruent, right? One's obtuse, one's acute. But is there ever a case in a rhombus where Q would be congruent to R? Is there sometimes, is that sometimes true? Q congruent to R. What shape is also considered a rhombus? We just talked about it. We just defined it. What shape is also considered a rhombus? Yes?
Square.
A square. Is Q congruent to R in a square? Yes. So sometimes Q would be congruent to R. All right. Any questions? There's the explanation. Same thing we just talked about. So be able to not only say always or sometimes, but also provide a reason. Everybody got the reasons? Okay. Classify the quadrilateral. What could we classify this quadrilateral as? Kaylee, what would I classify 2 as? Why? Right, it's a rhombus. You always want to classify it as its most specific thing. So, could you say this is a parallelogram? Yes, but we can be more specific. It's a rhombus, right? So it's a rhombus. 2 is a rhombus. 3, for any rectangle, EFGH, it is always or sometimes true that FG equals GH. Again, sketch it. Sketch a rectangle so you can visualize it. We've got E, F, G, H. Is FG always or sometimes congruent to GH in a rectangle? What do you think, Carly? Jacob?
Yeah, sometimes.
Sometimes. What's the case?
The case where it isn't, or
If what?
if it's a square.
Good. If it's a square. Again. They're next to each other. So, like in this picture, it's pretty obvious FG doesn't G equal GH. But, if this is a square, then they're congruent. Okay, so if it's a square, it would be sometimes be true. Number 4, a quadrilateral has 4 congruent sides and 4 congruent angles. Sketch it and classify it. Go ahead and do that. Sketch it, mark it as described, and then classify it. All right, here's a sketch. I mark the sides congruent. I mark the angles congruent. If it's a quadrilateral and they're congruent, they have to be right angles. What do we classify this as? Abby? Yeah, it's a square. Theorems. Here's some more characteristics of these shapes. Again, do not Learn it by the number. Learn it by the idea. A parallelogram is a rhombus if and only if its diagonals are perpendicular. All right? In a parallelogram, the diagonals bisect each other, but not necessarily are they perpendicular. Only in a rhombus. Only in a rhombus will the diagonals be perpendicular. The next theorem. A parallelogram is a rhombus if and only if each of its diagonals bisects a pair of opposite angles. So these angles are this line AC bisects angle A and it bisects angle C. Right? They bisect the opposite angle. These angles are bisected in a rhombus. In a parallelogram, so this picture is not right because this picture is not a rhombus. We need to correct that. Okay? But this is an example. Let's take a look at this. So this doesn't have congruent sides. You can see this angle here is smaller than this angle. At angle D. Those two angles are not the same because the sides are not the same length. So we'll sketch a rhombus. You sketch a rhombus. Now these angles are the same. This is a rhombus. Those angles would be the same. And also these angles would be the same in a rhombus. Parallelogram. The next one, a parallelogram is a rectangle if and only if its diagonals are congruent. It's a rectangle if the diagonals are congruent. Now, if this is a rhombus, it's pretty obvious this diagonal is longer than that diagonal, right? Rectangle, the angles, the four right angles, these lines are going to be congruent. All right? They bisect each other because it's a parallelogram. They're not perpendicular because it's not a rhombus, but their length is the same. So like I said, it just takes some memorization. As you do the homework, go back and look at your notes, see the idea, and then as you answer questions about it, you'll start to learn them. All right? Learn the characteristics. Sketch a rectangle ABCD. List everything you know about it. Go ahead and do that. Sketch a rectangle, mark it appropriately, and then to help me create my list, I would draw in diagonals and say what's special about diagonals and things like that. All right, so go ahead and take a second to do that. All right. So, okay, let's go back here. So we have a rectangle. We sketch it. Okay, so one thing we know about it, it has 4 right angles, right? 4 right angles. That's one characteristic. What's another characteristic? Some of the characteristics we know because it's a parallelogram. What do we know about it because it's a parallelogram? Aaron? Right. We can mark the opposite sides congruent. So we can say opposite sides congruent. Okay. What else do we know about it? Yes. Yes. That's special only to a rectangle, not to a parallelogram, but to a rectangle. We can say the diagonals are congruent. What else do we know about the diagonals? Because it's a parallelogram. What else do we know? Well, we just listed that. The diagonals are congruent. What else do we know about the diagonals? It's true of any parallelogram, not just a rectangle. What do the diagonals do to each other? Right. Diagonals bisect each other. So we've got that marked. Anybody think of anything else special about a rectangle? All right, it'd be a good idea maybe before you do the homework to do the square and the rhombus. Then you could look off of that as you did your homework, knowing those characteristics. Make a list for each one. All right. I don't think this is in your notes, but here's an example. You're building a frame for a window. The window will be installed in the opening shown in the diagram. All right. So, obviously the window is a parallelogram, right? The opposite sides are congruent. The opening must be a rectangle. Given the measurements in the diagram, can you assume that it is? Can we assume this is a rectangle? Triangle. Why? Looks like a rectangle, but can we for sure assume it's these? They call this the window being square, right? It's not actually a square, but when they say the window is square, okay, what would tell me? Well, how? What do I need to know if this is to say this is definitely a rectangle? Yeah. That tells us it's a parallelogram. We've already established it's a parallelogram. What would I have to know this is a rectangle? How did we define rectangle?
All the angles.
Yes, these have to be right angles. That's why they say the window would be square. Each corner is a square, a 90-degree angle. We don't know that yet. So we don't know if this window is square, if it's a rectangle. So you measure the diagonals. The diagonals. Okay, so we measure across here and we measure across here. The diagonals are 54.8 and 55.3. What can we conclude about it? Is it a rectangle?
No.
Why not?
Because the diagonals are not congruent.
Right, the diagonals aren't congruent. So when you went to install the window in this opening, when you put the window in there, you'd have to really do a lot of shimming. Anybody know what it means to shim a window? Okay, that means you put little strips of wood. They're about this thick. They're shaped in like a little triangle. They taper off, and you break them off to fit into the spaces. You'll put the window in. There would be gaps. So to get the window to be level, you would put in some shims and maybe in this corner and this corner. Put a shim up here and a shim here, and that would kind of make the window so that it sits in there straight, right? So or the window wouldn't fit. It may not fit in there because it's not square. The diagonals have to be congruent. All right. So we've got some extra time.